good day. So, ngayon, ang itatapil natin is about solving trusses, beams, and frames. Okay? So, this is a general lecture natin kung paano natin isolve yung mga iba't ibang uri ng structures. Okay? So, in the theory of, under the subject theory of structures. Okay? Or structural theory. Paano nga ba isolve yung truss, beams, and frames? Okay. So, you might ask, ano bang ibig sabihin natin kung ano yung isosolve natin? Okay, so when we say solve, we are going to compute computations of support reactions. Okay, so isa yan. Internal reactions. Okay, so kapag sinabi nating internal reactions, marami yan. Okay, so may tinatawag tayo na shear. Okay, so moments, shear, saka axial loads. Okay, and then deflections. So, ito yung usually kailangan nating malaman when solving trusses, beams, and frames. Okay? So, i-compute natin yung support reactions at yung internal reactions saka yung deflection. Okay? So, usually, dito tayo sa first two. Itong support reactions at internal reactions. Okay? Ito yung masosolve natin using, specifically these two. We can solve these two using statics. Okay, kapag determinate siya. Okay, so yung hinahanap natin pag nag-solve tayo is yung support reaction, internal reaction. Kapag internal reaction, marami yan. Moment, shear, and action loads, and then deflection. Okay, so yan yung ibig sabihin natin kung ano yung sinusolve natin. Okay, so lagay ko dito what we are. Okay, so ito yung ibig sabihin natin ng solving. Okay, pag sinabi natin solving, computations na nito. Okay, so ano yung unang gagawin natin before tayo mag-solve ng trusses, beams, and frames? Okay, so yung yung first nating gawin, okay, so in the past videos is you determine the degree of indeterminacy or determinacy. So, yan yung second. Okay? So, this is the second method we should do. Okay? So, bakit natin kailangan i-determine yung degree of indeterminacy and determinacy? Okay? So, if nanood kayo nung nakaraang yung past videos ko na na-upload, malalaman natin kung bakit kinukompute natin yung degree of indeterminacy or determinacy niya. Nang sa ganon is hindi na tayo ma-identify natin whether determinate or indeterminate yung truss, yung beam and frames natin. Okay? So let's just have our own review. So bakit nga ba natin kailangan i-determine muna yung degree of indeterminacy and determinacy ng trusses, beams, and frames. Okay? So, una, okay, i-discuss natin to. I-rediscuss natin yung determinate at saka indeterminate. Okay? So, ito yan. Pag sinabi kasi nating determinate, solvable by statics, basic statics. Okay. So, ano yung mga basic statics na pamamaraan? Okay? So, ito yung mga force, ito yung magagamit mo. Okay? Summation of forces X is equal to 0. Summation of forces Y is equal to 0. And summation of moment is equal to 0. Okay? So, kapag determinate siya, solvable siya by basic statics. Kapag indeterminate kasi siya, ibig sabihin, cannot be solved. By basic statics alone. Okay, so this is just my simplified definition. Okay, so masabi natin na ang structure, whether truss, beams, or frames is determinate kapag solvable siya by basic statics. Indeterminate kapag otherwise. Hindi siya solvable by basic statics alone. Kaya nga napag-usapan natin kung paano i-determine yung degree of indeterminacy or indeterminacy ng truss, beams, at saka frame. Okay? So, if naalala nyo, kapag trusses, tatlo lang yan. Okay? So, if B plus R minus 2J is less than 0, okay, in which ang B mo is the number of bars or the number of members, and R is your number of reactions, at saka yung J nyo is the number of joints. Okay, so ito is statically unstable. And then, kapag B, yung B plus R minus 2J mo is equal to 0, then it would be statically determinate. Yan. Ibig sabihin, statically determinate siya kapag B minus R minus 2J. So, kapag ganon, magamit mo tong formulas na to. Or, kapag lumagpas naman sa 0, magiging statically indeterminate siya. Yan. So, this is just a review. Okay? So, sa hindi nakapanood nung nakaraang video, so I will, maybe I will just put the link of the videos, those videos, previous videos on the comment section. And then, ipipin ko. Then, meron tayong, and for beams and frames, tatlo lang din yan. Okay? So, R minus 3N yung gagamitin natin. Kapag less than 0, statically unstable siya. Okay? SU, statically unstable. Kapag R minus 3, N is equal to 0, ibig sabihin, statically determinate siya. Okay? SD. Shinortcut ko lang, statically determinate. Kapag R minus 3N is greater than 0, ibig sabihin, statically indeterminate siya. Okay? So, yan. So, bakit ba natin, ano bang significance nito? Okay? So, ang unang konsentritan muna natin is itong nasa gitna ng trusses tsaka ng beams at frames. Itong for trusses, B plus R minus 2J is equal to 0. At ito sa frame, dapat R minus 3N is equal to 0. Okay? So, kapag na-identify mo, na-determinate siya, dapat nag-0 ang formula na to at nag-0 itong formula na to o depende kung truss o beams o frames yung isosolve mo. Kapag ang result niya is 0, automatically masolve mo yung problem na yan using these 3 equilibrium equations. Okay? These 3 equilibrium equation by statics. So kapag hindi, okay, kapag less than 0 siya, ibig sabihin, statically unstable, hindi mo siya masolve. Hindi mo siya masolve. This statically unstable is never solvable. Kahit anong gawin mo. Itong statically indeterminate naman, hindi mo siya masosolve kaagad by basic statics alone. Okay? So, you need to apply some methods. Okay? In order to solve it. Okay? You will use formulas good for solving indeterminate structures. But we are not still going to discuss it. Yung una nating i-concentrate is yung C-determinate structures. Whether trusses, beams, and frames yung isosolve mo. Okay? So, dito muna tayo sa determinate structures. Into which, kapag trusses, B plus R minus 2J is equal to 0. And then, R minus 3N is equal to 0. Okay? So, dito tayo sa dalawang formula na to. Okay? So, kapag by determining the degree of indeterminacy or determinacy, 0 yung resulta, ibig sabihin determinate structure siya. Pwede mo siyang isolve using these equations. Okay. So, yan. So, yan yung sinasabi ko. Kailangan mo munang i-determine kung determinate ba siya. Kapag hindi siya determinate, huwag kang magpagod. Huwag mong gamitin itong yung dati mong nalaman sa statics alone. Kahit anong gawin mo, hindi mo masosolve yung problem na yun using these 3 formulas alone. Okay? So, those structures are need of additional infos. Okay? And or we will use for other methods only for indeterminate structures. Okay? So, yan yung mga steps. First steps na dapat mong i-consider when solving truss, beams, and frames, which is the degree of indeterminacy or determinacy. Kapag determinate, then go na. I-solve mo using statics. So, okay, so may I erase all of these things. So, mag-concentrate tayo sa determinate structures. Okay? So, magsimula tayo kay truss. Okay? So, magsimula tayo kay truss. So, pag sinabi nating truss, it is composed of members. Okay? It is composed of members that are usually is slender. Okay? So, ibig sabihin is, it is generally assumed that in a truss, yung mga members niya is slender. So, the only reaction or the only force that is acting on the truss is axial. Okay? Okay, so when it comes to reactions, okay, so I would like to reiterate this one. In terms of reactions, okay, support reactions lang. Okay? So, in terms of internal reactions kamo pala, internal reactions, the only thing na kaya niyang dalhin is axial forces. Okay? So, into which, okay, so let us say na itong unit na to, okay, so let us say this member, itong nasa gitna na nakatakilid, it's either it can only sustain or it can only support axial tension, and the other way around, it might also support axial tension and axial compression. Okay. So, kung hindi nyo naalala yung definition ng axial tension at saka ng axial compression, okay, so maybe linawan natin yung pagkasulat. So, this is axial tension. And this is axial compression. Okay. So, pag sinabi nating axial forces, dalawa lang yan. Itong axial tension tsaka axial compression. So, maybe i-review natin ano yung axial tension at saka axial compression. Kapag sinabi mong axial force, okay, itong axial force, it is a force, okay? Pag sinabi natin axial force, it is a force that is parallel to the length, okay? Parallel to the length. Forces parallel to the length of, okay? Maybe dito ko isulat sa kabila para mas malinaw. Okay, so when we say axial forces, just a review, are forces parallel to the length of the member. Okay? So, kung ito yung length ng member, parallel sa kanya yung force. And then, yung force niya is opposite in direction on each of the end. Okay? So, kapag yung axial force is ganito, axial tension siya. Kapag tension kasi parang hinihila siya. Okay? Parang nililengthen siya. Okay? Axial tension tends to extend the length. O axial tension, parang hinihila siya na parang ganito. Okay, parang hinahaba. Okay? In both the opposite directions, para siyang binibinat mo siya. Okay? Na axial tension usually is an attempt to increase the length of the member. Samantalang ang axial compression, it shortens the length. Okay? So, kapag tension, it tends, okay? Tends to lengthen, okay? The member. Okay? So, and then kapag sinabi nating compression, okay, we are speaking of axial tension and axial compression. So the axial compression, the member tends, okay, to shorten the member. So ganyan yung pagkakaiba nung axial tension at saka nung axial compression. Yung axial tension, dalawang force, parang, okay, hinihila siya on both ends, kaya parang hinahaba niya yung member. Okay, tends to lengthen the member. Yung axial compression naman, it tends to shorten the member. Yan yung kaibahan ng axial tension saka ng axial compression. Okay. Yan yung, it is the only force that the truss can support. It cannot support other forces. So it cannot support bending moments, and it could not support shear forces. And also, generally, it cannot also support torsion forces. So, the only thing na kaya the truss is the axial forces lang talaga. And then, kapag sinabi nating axial forces, it's usually axial tension or axial compression forces. So, ano nga ba? Okay, so, you might ask. Okay, so merong other terms yung axial forces. So, yung axial force is also called normal force. Okay? So, other term for axial force is the normal force. Okay? So, kapag nakarinig kayo ng ibang source na sinasabi nila instead of axial force, normal force yung kayang isupport the only reaction that truss would support, then it is also correct. Dahil axial force and normal force is basically the same. So, yan yung properties ng truss. Okay? Axial forces lang yung kaya niyang buhatin. Walang bending moments, walang shear forces. Okay? So, speaking, okay, yan yung truss. So, paano naman kapag beams and, okay, paano naman kapag beams and frames? Okay? So, maybe I will erase this one. Okay? So, since video ito, pwede nyo lang i-replay yung portion ng video na hindi nyo masyadong naintindihan, and then recomprehend or rethink or try to understood it, okay, by repeating what I have said. Okay, so doon tayo naman kay beams, okay, tsaka kay frames. So, ano tong dalawang to? Okay, so pag sinabi nating beams, horizontal component lang siya. Okay? Okay, so yan yung beams. Horizontal component only. Okay, so maybe I will draw different types of beams. So meron tayong fixed on both ends. Meron tayong simply supported beams. Okay, so meron din tayong okay, cantilever beam. Okay, so cantilever to. Okay. And then meron din tayong tinatawag na prop. So this is okay, fixed simply supported then this is cantilever and this is prop. Under, okay. And this is prop beam. So maraming iba't ibang uri ng beams and many others. So yan yung definition ng beams. Horizontal component only yung makikita mo kay beams. Okay? Whereas in frames, okay? Yan yung kay beam. Yan yung kay beam. Sa kay frame naman, okay? So, sa mga frames naman, maraming pwede. So, kapag frames, it is composed of both horizontal, okay? Both horizontal and vertical components. Yan. Yan yung kaibahan ni beams tsaka ni frame. Si beams, horizontal component only. Kapag frames, both horizontal and vertical. So, ito si frames. Meron, okay? So, kapag sinabi nating frames, meron kang beam, meron ka pang column. So, yung nakatayo, okay? So, beam is the horizontal component. And then, column is a vertical component. So, yan yung beams, tsaka, ang kaibahan ni beams, tsaka ni frame. Si beams, horizontal component lang meron siya. And then, si frame, is composed of both horizontal and vertical components. And then, the horizontal component of that frame is also called beam. Okay, beam. And then, yung vertical component niya is column. So, yan yung pagkakaiba ni beams tsaka ni frames. Okay? So, yan. So, when it comes to reactions, okay, so when it comes to internal reactions, both beams and frames are what are they are capable to do. Okay. Okay, so may I erase this one? So for beams, and frames, they are capable. Okay, they are capable of, okay, so when in terms of internal reactions, marami siyang pwedeng masupport. Pwede siyang mag-support ng bending moments or just simply moment, and then shear forces, and then it can also support, axial, also called as normal forces. Okay? So, unlike kay truss, si beams tsaka si frames kaya niyang mag-support ng bending moment, kaya niyang mag-produce ng internal reaction na bending moment, shear forces, tsaka axial and normal forces. Okay? So, maybe, we will revisit ano ba tong bending moments, shear force, and shear forces. Okay? So, alam niyo naman yung axial, normal, or normal forces into which parallel sa length ng member yung axial force. So, let us say, meron kang beams na ganito. Okay. And then, simply supported beam. Sinabi natin simply supported beam. Okay, so this is just a review. Okay, a review of your statics. So, kapag subjected siya into certain loads, for example, this, so, meron siyang bending moment na ganito yung forma. Okay? And then, hindi siya bending moment, this is shear forces. So, this is in terms of V. And then, bending moments is M. And then, yung normal, axial or normal forces, N siya, usually yung so, meron siyang shear diagram. And then, meron din itong MT or moment diagram na ganito yung forma. Into which, yung M-max niya is nasa gitna kapag simply supported. Otherwise, pwede rin na yung maximum moment niya is nasa ibang location. Pwede nasa supports or somewhere in between. Okay, so it can be left support, right support, or in between yung maximum. But for a simply supported beam, yung M-max niya is nandito sa L/2. Or if this is the length. So this is, okay, so this is shear forces. Shear force. Okay, so this is, okay, this is shear force diagram. And this is the moment diagram. And usually, meron din tayong, pwede rin tayong maglagay ng axial force diagram. Okay? So, tatlo yan. So, maybe, naalala nyo, baka moment lang or shear lang yung dinodrawing nyo. Or kinocompute nyo yung dati. But somehow, today, posibly meron din siyang axial and normal force. Okay, so here, in this type of beam, 0 yung axial force niya. Okay, for simply supported. But somehow, in some other types of beams, for example, prop, let us say prop beam, na ganito. So, there is a possibility, okay, so prop beam, dapat dito sa kabila is, kaya din niyang mag-support ng, okay, so ganyan. So, posible na yung reaction niya sa moment is meron siyang negative moment dito. Okay, so kapag ganito, fix dito sa isang banda at saka pin dito. So there is a possibility. Okay? So there will be a moment, okay? So a negative moment here at the fixed support. Either negative or positive moment. Okay? So basta okay, so this diagram is not, the moment diagram and the shear force diagram is not the same with the simply supported beam. Okay, so here, there is a possibility na may horizontal force. So kapag may horizontal force, you will have an axial load diagram. Or axial force diagram. Okay? So, axial force diagram can be also drawn if there is an axial force. Okay? So, paano nga ba yung axial force ng beams? Okay? So, yung shear forces unlike axial or normal forces, is yung perpendicular. Okay? So, kapag okay, so maybe we will define what is shear force and what are bending moments. In simple words, So, this one. So, kapag sinabi kasi nating shear or shear forces, it is force perpendicular to the length of the member or the component. And then, in contrast to the axial or normal force na parallel. Okay? So, the same citation. So, kapag sinabi nating shear force, force perpendicular to the length of the member, and then axial or normal force is force parallel to the length of the member. Okay. So, kapag bending moment naman tayo, so it is simply, by simply definition, is something that bends the member. Okay? So, parallel. Okay? So, it bends the member parallel to the length. Okay, so it is something that bends the member. So, if this is your member, yung bending mo is pa ganito. Okay, so kapag may bending siya, it will bend into the direction. Okay, so it will bend into the direction, no, not parallel but perpendicular to the member. So, kapag ito yung member mo, okay, so kapag ganito yung, maybe gamit tayo ng ibang, ibang word. So, pag sinabi kasi nating, so pag sinabi nating, so kapag sinabi kasi nating bending, okay, so kapag sinabi kasi nating bending, ito yung member natin, for example, and then subjected siya into loads. Let us say W is equal to 8 kilonewton meter. So, yung forma niya is maggaganito siya. Okay? So, ganyan. So, there is what we call deflections. Okay? So, kapag may bending sa member mo, meron siyang deflection. Yung bending, okay, yung bending yung nagkukos na mag-deflect yung beam mo. Perpendicular to the member, not parallel. So, ganyan yung si bending. Okay, something that bends the member. Okay, so other thing that could not be seen in the 2D representation other than the bending moment is we also have, okay, so we also have the torsional moment. Okay. So, by definition, so balikan natin. So, yung bending natin is pag ganon. So, ito yung member mo. Kapag may bending is ganito yung magiging forma niya. Because of forces. So, from this position, so magiging ganito siya kapag subjected siya into loads. Samantalang yung torsional, okay, so torsional moment, yung bending niya, perpendicular. Okay, so parang pinapaikot niya. Okay, so pinapaikot niya, wina-warp niya yung cross-sectional area mo. Ito, parallel to the length. Ito, ay perpendicular to the length. Yung deflection niya. Ito, pero parallel to the cross-sectional area. Ay perpendicular to the cross-sectional area. Ito, parallel to the cross-sectional area. Kumbaga, itong beam na to, may cross-sectional area siya. Let us say, rectangle. Ito yung length, ito yung deflection niya. Kay torsional moment, pinapaikot din niya, pero dun sa sideways. Okay, so dun sa other side ng beam. Okay, so it is just incrementary information. So, ganyan yung kaibahan. Ng trusses, ng beams, tsaka kay frames. Okay? So, sana meron kayong naintindihan sa video na to. Okay? So, this is just an introduction. Okay? So, later on the next videos, we will try to solve numerous problems regarding the computations of trusses, beams, and frames. But we will start with those determinate ones. After we solve numerous beams, trusses, beams, and frames, which are determinates, then later on, we will also discuss how to solve trusses that are indeterminates, beams that are indeterminates, and frames that are indeterminates. Okay? So maybe this will be for now for this video, and then I hope you will also watch my next set of videos.